All right, so here we go. We're going to talk about molarity. We're going to talk about dilution, and then we're going to do a little bit of math associated with that. And it's not hard math, actually. But in order to talk about molarity, we need to talk about concentration. Concentration is really the ratio of how much stuff is dissolved in a specific amount of water. The more stuff that you have dissolved in water, the more concentrated it is. I like to use the analogy of when I was a kid. We went to like Six Flags, which when I was a kid was called Great America. And you know how they sell those like lemonade ice cups where you walk around, you eat, and they're so good, right? And my mom was like, "You were not going to buy those; those are too expensive because they were like, I don't know, like $5 or $3 a thing." So my mom was like, "We're not. That's too expensive." And I was like, "Well, but it's good." And she's like, "No, we're not." So then I went home and I made what I called poor man's lemonade in a cup, which was my mom always had like the frozen concentrated lemonade and orange juice when I was a little kid. So I just opened that up and just ate it right out of there. You know what I'm talking about?
Yeah, I know.
So like when you do that though, like that's super concentrated because they took all the water out of it except for just a little bit to freeze it. And when you make lemonade from concentrate, you take that giant turd of a can, like you know what I'm talking about? It comes out like a turd.
Yeah.
No, you don't.
I know.
Okay, and it just lands in the bottom of the thing. Then you add like 3¼ cups, which I never understood that, or cans. Like, how am I supposed to measure? Like, you'd think these people would have a much better measuring system. Like, we're just going to do 3¼ cans. Like, what are you talking about, quarter can? Like, how am I supposed to estimate that? Like, where's the meniscus there? You know what I'm talking about? No.
Like butter, how they have the little lines.
Yeah, right. That'd be great if they had like butter, but they don't. So anyway, so you make the lemonade, and if you put too much water in, it's really dilute and it tastes like garbage. If you don't put enough water in, it's really, really sour, and I like it that way. So I always avoid that quarter situation. But that's what concentration is. How much water is added to a substance so that substance or when that substance dissolves. Thank you. So the more concentrated something is, the more stuff is dissolved in a specific amount of water. Things that are higher concentrated will have a larger effect. So when I think about the lemonade situation, if you take the lid off that can and then you just lick the lid because that's what you do, right? It's super sour. But if you take that same little bit of can lid and throw it in a glass of water, you can hardly taste it. So that's the difference between concentration with lemonade and concentration. Now we're going to talk about concentration with solutions. So if I take 20 grams of sodium chloride and put it in 100 grams of water, it's going to taste saltier than if I put 10 grams of sodium chloride in 100 grams of water. It's just more concentrated. So molarity is a quantitative way to show concentration, and there is a formula associated with it. Molarity is moles of solute divided by liters of solution. So anytime we do these problems, the top part will have to be in moles, will be the unit, and the bottom part has to be in liters, the unit. Okay. Now, weirdly, chemists have been like, well, you know what? So you know what the variable for molarity is? They're like, well, that's just going to be a capital M. So that's what we're doing. So the capital M is the variable for molarity. So when I rewrite this, like as most people will, it's just moles over liters. So what that should tell you is that if you have a mass, you have to convert mass to moles in a problem. Or if you have a volume in milliliters, you might have to convert it to liters. So if we have a mass, we need to convert it to moles using the molar mass. And if we have a volume in milliliters, we have to convert it to liters using the relationship that 1,000 milliliters is equal to 1 liter. Okay, so those are things that you might need to know. So the easiest way to work through these types of problems is to simply do a bunch of examples. And so we'll run through a couple of examples right now. here's the question: says, what is the molarity of a solution in which 125 grams of NaOH is dissolved in enough water to make 0.8 liters of solution? So if I identify my variables like I always do, molarity, moles. Yes. Molarity, moles, liters, and then we're going to have mass. So the problem tells me that I have 125 grams of NaOH, and I'm making enough solution to make 0.800 liters of this solution. And the problem wants me to find the molarity. But in order to do that, I have to remember that molarity's formula is moles divided by liters. So the first step that I have to do, because I don't have moles, is convert mass to moles. So step one would be convert mass to moles. So I'm going to take my 125 grams of NaOH, put it over 1, and go to moles. So when I want to calculate the number of moles, I need to find the molar mass off the periodic table, right? So in this case, I have 1 sodium times 22.99 grams of sodium. And I have 1 oxygen times 16.00 grams of oxygen. And I have 1 hydrogen times 1.01 grams of hydrogen. And I add all that business up. So it's like 22.99 plus 16 plus 1.01. I get something like 40, I guess. So I get 40 grams per mole of NaOH. So now that I know my molar mass, I'm going to put that on the bottom. And I'm going to put 1 mole on the top. And I'm going to solve for moles. So 125 divided by 40 gets me something like 3.125 moles of NaOH. Now, technically speaking, I should round this to have 3 sig figs, but I usually do my rounding for sig figs at the end. So now step 2 is I put it in the form is I use the equation. So step 2, substitute into the equation. So molarity will equal the 3.125 moles divided by the volume, which already happened to be in liters, so we're going to leave that alone. And so when I take 3.125 divided by 0.8, I get a concentration, or I get a molarity that's equal to like 3.90625. But now with sig figs, I have to have 3 sig figs. So 1, 2, 3, I draw a line. That's 6, will round that 0 up. So my actual answer is 3.91 molar NaOH. And that's pretty nasty stuff. I wouldn't want to deal with that. So what that tells me is that's the ratio of essentially moles or grams to liters. So that's kind of a lot. The bigger the number, the more concentrated it is. Does that make sense? If this were like acid, that'd be pretty bad. But this is a base, so it's also not really good. So we'd want to kind of avoid that. All right, so another example, because why not? Actually, tell you what, why don't you try this example? There's it might be out right now, but this is for you. You give this one the old GHS try. Go ahead, give it the old GHS try. You know what I'm talking about? Yes, sir.
Copying your tattoo.
All right. So if you worked your way through this problem, hopefully you ended up with 0.43125 moles of sodium sulfate. as the first step here. From there, you had to convert moles of sodium sulfate to mass of sodium sulfate. And so at that point, then I needed to calculate the molar mass of sodium sulfate. And then I found it to be about 142 grams. I then multiplied straight across. I got 61.259, which I needed to round to have 3 sig figs. So I got 61.3 grams of sodium sulfate right here. Questions? Hopefully you don't think that is too difficult. It is a type of problem that we do often in this class. As a chemist, you calculate molarity all the time. So there's that. The other thing that we need to talk about today is something called dilution. So dilution is a method by which we take a concentrated solution, something that of a known concentration, and we take a sample of that and we make that sample become less and less concentrated depending on how much water we add to it. So in a lab setting, a lot of times what we do is when we buy chemicals, those chemicals come to us at a very specific concentration. For example, hydrochloric acid comes at 12 molar, which is really kind of powerful, potent stuff. But when you use it, you usually use it somewhere around 0.1 molar. So what I do is I take a specific amount of the 12 molar acid and I put it in a lot of water, and then it becomes less concentrated and a lot easier and a lot safer to handle. So that's what dilution actually is. It's the process of decreasing the concentration of a solution. Oh, shit. Okay. All right. Ooh, sorry. My wife got rear-ended. So cool. Dilution is the process of decreasing the concentration of a solution by adding increasing amounts of water to it. So something that we refer to as the stock solution is the solution that we always draw from. Okay. So in the case of hydrochloric acid, our stock solution might be something like the 12 molar, the way that it comes from when we buy it from the acid store. Yes.
Did your wife feel like that?
Yeah, apparently she's fine. Thank you. So at that point, we can then take out small samples of the stock solution and add it to differing amounts of water. And when we add it to differing amounts of water, the solution itself becomes less and less and less concentrated. Okay, so that's what dilution actually is. There is an equation for it, and it's actually a pretty simple equation. It's M1V1 equals M2V2, where M1 is the concentration of the stock solution before dilution, and V1 is the amount of stock solution used during dilution. M2 is the concentration of the solution after dilution, and it's the total volume of the final diluted solution. So it's a pretty simple formula, and it's pretty simple to go through and do an example or two of. So here we go. If we have M1, V1, and M2, V2, all right, so how much 2 molar sodium hydroxide solution should be diluted to prepare 100 milliliters of a 0.5 molar solution? So my original concentration is 2 molar, and I'm trying to figure out how much of this to use. My new concentration that I want to find is 0.5 molar, and I'm going to make about 100 milliliters of it. So I set up my equation to be M1V1 equals M2V2. So I just substitute in my values, 2 molar, and then M2 is 0.500 molar, and V2 is 100 milliliters. So I simply combine what I can, which in this case is 0.5 times 0.1. 0.5 times 0.1. 0.5 times 0.1. Let's try that again. Okay. And I get something like 2.00 molar times V1 equals 0.500. And then I'm going to divide both sides by the 2. and 0.05. Oops, I copied that down wrong. That's 0.05 for those of you keeping along at home. And so then I divide that. Oh, wait. What did I do here? Okay, hold on. I converted the milliliters to liters in my head. Sorry. You don't need to do that for these problems. So 0.5 times 100 is 50. That looks a little bit better. Sorry. And that technically is going to be molarity times milliliters. So 50 divided by 2 is 25. So I'm going to need 25.0 liters to make this particular solution. So here's another example where we have M1 V1 and M2 V2. So in this case, 100 milliliters of water is added to 500 milliliters of a 0.1 molar solution. What's the new concentration? So this one can be a little tricky. Some people see it, get a little tricked out by this. My original solution is 0.100 molar, and the original volume is 500 milliliters. And we're adding 100 milliliters to it. So if we're adding 100 milliliters, the new volume is going to be 100 milliliters plus 500 milliliters to give me a new volume of 600 milliliters. You see what I did there? Because that's kind of important. Hopefully. So M1 V1 equals M2 V2. So I've got 0.100 molar and 500 milliliters. And I'm looking for M2 and 600 milliliters. So 0.1 times 500 is 50 again. And that leaves me with M2 times 600. So 50 divided by 600 gives me a concentration of 0.08 with 3 sig figs would be 3 molar is equal to M2. Okay, there's one more example here that's going to clearly be a U try because that's how we do some things here. So go ahead and give this the old GHS try, the U try. So
Mr. V, do you have a hair tie?
I do not. So when I did this problem, I solved and I had to add again the volumes so that my new solution was bigger than the original solution. So I had to add my volumes there. And I knew that my final concentration over the concentration of my new solution was 0.350. So I had to solve for my original concentration, and my original concentration was quite concentrated. It was 1 molar. So any questions about this? All right. Your homework is to do the worksheet in the packet. It's worksheet number 4, I believe. That looks a little something like this. Yeah, it says U14 worksheet number 4, quantitative concentrations. It has like 3 molarity problems and like 3 dilution problems, and we will go over that tomorrow during class during virtual learning. So, any questions about today's lesson so far? Yes, sir.